Hi and welcome to aarna.ml GPU cloud management software demo. The purpose of this demo is to demonstrate how using the aarna.ml GPU CMS we are able to achieve the isolation for InfiniBand network fabric all through an automated way. Before we go into this demo, just wanted to also let you know that in case if you are interested to see how we do the Ethernet based network isolation using Spectrum X switches, we have the demo videos available on the YouTube. Please do have a look at that. And also, before we start on the actual demo, for those who are new, I'll just spend half a minute or so to let you know what this software is all about. So aarna.ml GPU cloud management software essentially enables the AI cloud providers or NVIDIA cloud partners to provide their infrastructure in a very much similar way of how hyperscaler provide their infrastructure. That is moving from static kind of GPU rentals to fully dynamic multi-tenant and on-demand infrastructure. We manage distributed AI cloud, so we manage the central cloud as well as edge locations. And there are two main functional blocks of our software. This block is the infra manager block, and this block is the PaaS block. So using the PaaS, we are able to provide the services like job submission, model serving. And this block helps the NCPs or AI cloud providers to have a full isolation for multi-tenancy use cases. And this isolation spans GPU and the CPUs. From a network perspective, it spans Ethernet and InfiniBand. It also spans external storage and also includes configurations for the external routers and gateways to have the isolation for the tenant extended to their ingress and egress traffic as well. So today in this demo, we will be concentrating on the InfiniBand network isolation. This is the topology that we'll be simulating or demonstrating in today's demo. Uh, so our software will sit on the management node, and we have different personas who can use this software. So one persona is an NCP admin who is the owner of the complete infrastructure. Another persona are the tenants. So tenants are essentially the enterprises or the end users who rent the GPU infrastructure. We have integrated with NVIDIA UFM, Unified Fabric Manager, which controls the InfiniBand network. So through UFM, we are going to interact with the InfiniBand network. So this is the integration that is shown, and this is the topology. This is a three-tier topology that we are going to simulate. So at the lowest level, you have the GPU nodes, and on top of that, you have a bunch of InfiniBand leaf switches. Again, on top of that, you have few more bunch of spine switches, InfiniBand, and on the top you have the core switches. So the three-tier topology is what we are going to discover, um, and the detailed demo steps are given here. So we'll all first start with discovering the topology. So what all the topology you see, we will discover in an automated way, and we'll get that into the aarna.ml GPU CMS inventory. Once the topology is created, then the second step would be that we start creating the tenants, because they are the one who are going to consume this infrastructure. So once we create the tenant, that is a time when the isolation mechanism that is used in InfiniBand, that is called P key, that will get created for that particular tenant. And once we have created that, we'll import few bare metal servers under this tenant, which is step 3. And to achieve the isolation for this, what we do is we associate the P keys with the GUIDs of the InfiniBand port. So let's now move into the demo. So let's first start with logging into the NVIDIA UFM. We are entering the credentials and logging in. Let's first see the network topology. So this is the network topology that we will be importing into the aarna.ml GPU CMS that we saw some time before. This is a three-tier topology. This topology is in line with the NVIDIA recommendations. So here you see that each GPU node is connected to four different leaf switches. And in this example, there are total eight InfiniBand ports per node, and two ports are connected to every leaf switch. This tab shows all the network devices that are part of this topology. So this covers all the leaf, spine and core switches. And you can see the GUIDs, what is called as a global unique identifier for InfiniBand ports. Very similar thing like MAC in the Ethernet world. Let's also see the existing P keys. Currently, we only have one P key for the management network. Since there are no tenants, we'll not see any other P keys in place. Let's log in now to the CMS as an admin and start with topology discovery. Let's provide all the details for integration with the UFM so that we are able to call the UFM APIs and initiate the discovery process. The discovery is going on. Yeah, and this is the topology that we discovered, the same topology that we saw in the UFM GUI, a three-tier topology. So now we have all the hardware nodes, the InfiniBand switches, their interconnections captured in the CMS. Uh, Now let's go and create a tenant. So we are going to create a new tenant. Let's name it something. So now when we are creating this tenant at the background, the CMS will be creating one P key. So P key is an isolation mechanism for the InfiniBand network. Let's go and check in the UFM GUI. Yeah, and here you can see that a new P key has been created. So now the next task for us would be go and allocate the bare metal resources to this particular tenant. We are doing that from an admin persona just for simplicity, but otherwise this could be done by the tenant user. Let's go and allocate resources. We are selecting the fixed template, select bare metal, and select few things from the catalog. Currently there is only one entry, so let's create that. Just select that flavor. Give other details such as OS details, the CUDA version, number of servers. Here we want two servers. Select the pricing and then go for allocating that. So here you can see that we have been allocated two nodes with the server names ending with H03. So once we have allocated the bare metal instances to the tenant, what we have essentially done in the background is we have mapped the P key for that tenant with the GUIDs. So let's go and quickly see those on the UFM GUI. Let's refresh it. Yeah, so you can see the list of all the GUIDs that are associated with this P key, which is API P key 01. So that is the P key that got created for the tenant. And if you recall, we allocated two servers, and all in all, in total, there would be 16 InfiniBand ports which are part of both of those servers. So you can see the whole complete list of the GUIDs which are part of that P key. Let's go and validate it. So let's select one of the GUIDs of this server and go back into the CMS GUI to see that the GUID is part of that. Yeah, you can see that it is part of it. Let's now select a different server also and validate the same thing. So here we have selected the IB1 interface, and you can see that that is part of the same P key. So that's essentially the whole demo, where we started with the discovery of the InfiniBand network through UFM. Once the discovery was done, we created a tenant, and once we created the tenant, at the back end we created a isolation for InfiniBand network which is called P key. Then we allocated the server nodes to that tenant, and then all the GUIDs which were part of those two server nodes, those were mapped to the same peak. So with this information, InfiniBand is able to isolate the tenant traffic. So this is all what we had for today's demo. Thank you. Thank you very much for watching.